Okay, so Math 7, we are in Section 3, but we're in Day 2. So you don't need to write this down. We're in Day 2. What I want you to do is a little homework quiz right now on your homework. So go ahead and pause the video here. Take these examples, these expressions down, and I want you to simplify them. Once you've done that, come back and check your work. Make sure it's correct before moving forward. Okay, so how about number 1, Michael?
I got negative 35 a to the 7.
Very good. We have 7 k factors. And number 2, Sarah?
Negative 24 g to the
Negative 24g to the
8.
I have 6 g's here and 6 more.
Oh. Oh, I thought that was 2. Then it's to the 12.
To the 12. Good. And how about number 3, Keelan?
4x to the second, y to the second.
Do you agree? Good. Because these 5 x's are canceling with 5 of these, right? So we have 2 left. And this 1 y is canceling with 1 of the y's in the numerator. So good job. And, okay, Carla?
And the 4. Is it c to the 12?
Well, if you were to expand this, you would have this entire fraction how many times?
3 times.
3, so we could go c to the 6th over a squared times c to the 6th over a squared times c to the 6th over a squared. So how many c's are in the numerator?
6.
6 plus 6 more.
18.
18. So c to the 18th over a to the 6th. Good job. So we really see when we have the power of powers, we multiply, right? 6 times 3 is 18. 2 times 3 is 6. Okay? So today we are going to just kind of use this a little bit and also talk about square roots, because the inverse of exponents is taking roots. Okay? So take this down and then come back and we'll talk about it. Okay, so I have found a rectangular prism. And so we have not covered prisms yet this year, but you have covered them in previous years. And so can anybody here define what makes this a prism? Michael?
3D.
Okay, but we have 3-dimensional things that are not prisms. So for instance, this is not a prism. And so what's the difference between this and that one up there? I mean, or could you give me a name for this? What is this figure?
Pyramid.
It's a pyramid. Good. So a pyramid has one base and then a vertex opposite it. So they always appear to be kind of pointy, right? But a prism has instead how many bases? Well, let me see if I can find another one. Here we go. This is another prism. So, do you see how? What do you think what do you think we would call the base of this figure I just found? Would it be these rectangle sides, or would it be the pentagon here?
Pentagon.
It's the pentagon. And so, can you envision what's opposite the pentagon? What's on the opposite side? Another pentagon, which is absolutely congruent to, it's a clone of this first one, right? So prisms have 2 parallel opposite bases, like that. Now the thing that makes this one unique up here, the rectangular prism, is what?
All of them are.
Good, Keelan is saying all of them have an opposite congruent clone, right? That is parallel to them. So rectangular prisms are unique in that way, okay? So that's what we have. We're being asked to compare the volume of one prism, and let me duplicate it. What happens when we expand a side by a factor of 3? So we could say that, I'll turn it down here. We could say this one is volume equals 8s squared. So that means that this side is s and this side is s, and then the longer side across the top, right, this side here is 8. Now, if we compare it to a different prism where we have increased S by 3 times, what does that mean if I've increased it by 3 times? What operation is that?
Multiplication.
Multiplication. So we wouldn't call this S anymore. What would we call it? This side would be 3S or S3, but we usually put the number first, right? So 3S. And this side would be 3S. This other side is still 8, okay? So what do you think happens to the volume if I triple the S's like that? What do you think the first thing somebody might think? If I triple the side, I would triple the volume. It's kind of a logical thing. I mean, you know it's going to be bigger, right? The volume will be bigger, but when we take a look at it with the formula, if I have tripled the S, how do I write this into the formula? I can't just write S squared anymore. What do I have to say instead? And so is the 3 being squared? Is a side now 3S? The side is 3S. The 3S is happening how many times? It's happening 2 times. You see that? 3S times 3S. So it's squared. Because to find the volume of a prism, we have 3 dimensions, don't we? We have base times width times height, which is in this formula. We have 8 times the width times the height. There it is. Okay? So when we simplify this, we have 8 times, what is 3S squared? 3S times 3S.
9S.
3S times 3S is 9S squared. Good. So here's what we have now. We have volume that is not just 8S squared. It's 8 times what? 8 times, what's that number? 9S squared. So if I triple the S, what have I done to the volume? Triple S equals how much more volume? How much more times the volume? 9 times the volume. Okay? So 3S equals 9 times the volume. Okay? Not just 3 times the volume. So when we get into volume and area, when we lengthen one side, or let's say we lengthen 2 sides, the area will be affected in both dimensions, right? This tripling affected 2 dimensions. So it did not just triple the volume of the original, it increased the volume by 9 times, okay? What if I had increased the 8 by 3 also? What if I increased every single side by 3? How much greater would the volume have been? What is 3 times times 3 times times 3 times? 3 times 3 times 3. 27 times. Good. So if every side was triple, we would have a rectangular prism 27 times as big as the original, because every dimension is a factor in this formula. Okay? Okay, this is more what you're going to see in your assignment today, and that is how we can simplify radical expressions, starting with square roots. So actually, 7th grade, we're only using square roots. So we have a rule box here. So we are showing the square root of a squared, but let's first look at the square root of 6 squared. So when we look at the example here, 6 squared, what is 6 squared, Sarah? 36. So we could write this as the square root of 36. Do you know what the square root of 36 is? What number times itself? 6. Okay. So ultimately we want to go straight from here to here, right? Or from here to here. We want to be able to say the square root of 36 is 6. Or the square root of 6 squared is 6. So notice that squaring and square rooting are inverse operations, right? They we could kind of say they cancel each other out. They're inverse. So if that's true, then the square root of a squared, Carly, is what? Is a. Good. Because the squaring and the square rooting are inverse. So we just take the base out of the radical. Base a. So let's try this with some other numbers here, some other expressions. The square root of 25a squared. Go ahead and pause the video and come back and we'll see how this gets simplified. When you have a radical with more than one factor inside, you can actually expand this, like we were expanding things yesterday. Okay, we can say this equals 25, square root of 25 times the square root of a squared. We can deal with each factor independently like that. So what is the square root of 25, Sophia?
5.
5, and the square root of a squared?
A.
A. So there it is, 5a. So we're dealing with each piece, okay? Now when we look at 32, it's not a what?
Perfect square.
Perfect square, that's right. It's not a perfect square. So what did we do when we dealt with numbers that are not perfect squares? Earlier this year? We break them up, and the word in math for breaking up begins with F. Say it? Did I hear it? I thought I heard it. Did we say it? Huh? Well, it's kind of like expanding the number, giving you the factors. So it's called factoring, right? Factoring. So can you think of a large perfect square factor in 32?
16.
16. Good. 16 times 2. And then we also have the x squared. So we're just expanding this. Now, after we do that, we look for perfect squares. And you just said 16 was a perfect square. So we say, if I have the square root of 16, what can I take out of the radical?
4.
16 is in, so take a 4 out, right? 4. And is there any other perfect square factor inside the radical? 2. What's the square root of 2? No, 1 times 1 is 1. So 2 is not a perfect square factor. It's going to stay inside, isn't it? But can you take the square root of x squared?
X.
X, good. So take this 1x out because there were 2 factors of x in. And you multiply 4x times square root of 2. Okay? C, we're going to expand. And we're going to look for perfect square factors. It's a little more challenging because it's variables, right? So let's make a big radical. And I have how many a squareds if I have a to the 8?
4.
Good. I have 2, 4, 6, 8. It's another way of writing a to the 8. Okay? And then how many b squareds do we have?
6.
6. Squeezing another one in. We have 6 b squareds. Good. So for each a squared, how many a's can I take out?
1.
1. So I'm going to take out 1, 2, 3, and 4. A to the 4th is now outside the radical. And how many b's will we take out?
6.
6. Good, because I have 1, 2, 3, 4, 5, 6 pairs. So I have b to the 6 outside the radical. Very good. So when we look at the original expression and compare it to the simplified expression, what did we do to these exponents?
Divided them
By 2. We took half as many out. That makes sense, doesn't it? When you look at it expanded. Okay, and then here's another little example that wasn't here. But what would you do with, let me rewrite that. Square root of a to the 5th. That's not an even number, is it? So can you expand it? How many a squareds are in here? How can you expand that? How many factors of a are there? Good job, Carly. So it's a squared times plain old a, right? So how many a's will I take out? 1, 2. So this will be a squared times the square root of a. Okay, so they're trickier when you have an odd number of factors. 1 stays in, okay? Okay, you've got 3 samples to try. I only have 20 seconds left, so I'm going to you pause the video, come back and see the answers. And if you have these expressions, you are on the right track. If you don't and you need help, you'll have to come and see me, right? Your assignment is here. Be sure to check your odds. Those who are doing that are in good shape. So I want everyone to be in good shape.